All right, guys, welcome back to day 2 of working with our rational expressions. Today's going to be really similar to adding them, but this time we're going to subtract them. And there's just a couple things I need to remind you of and make sure you're really careful about, like remembering that you're minusing an entire thing, so put it in parentheses and distribute the negative and things like that. So let's get started. Let me first remind you again just how we would subtract fractions that don't have common denominators. You would do it in the exact same way that we did with addition, and you would get common denominators. Instead of thinking through what they have to be, remember a trick is that you could just times this one by 4. So do that to top and bottom, and then you could times this one by 28 and do that to top and bottom, and then you don't really have to think through the numbers. So if you grab your calculator and you type in 4 times 28, you'll get 112. So then I know I can make both of these bottoms 112. And this top over here would be 12, and this one right here would be 28. Oops, and I just realized I wrote plus and I meant to write minus. And let's see, 12 minus 28 is negative 16. So over 112. And let's see if I can reduce that. Well, they're both even numbers, so if you just divide them both by 2, we know that 16 divided by 2 is 8, so negative 8 over 112 divided by 2 is 56. Those are both even numbers again, so let's do that same thing again. Divide them both by 2, and you will get negative 4 over 28. Okay, those are still even numbers, so let's do that one more time, maybe. Divide them both by 2, I got 2 over 14. Divide them both by 2 again because they're still even numbers, and you'll get negative, 1/7. Now I'm finally at my final answer. So you can see that's kind of like the trick I do when I have big numbers and I don't really want to think through like what they're both divisible by. If they're even, I just divide them by 2. Divide them by 2, divide them by 2, and I just keep going until I can't go anymore. Okay, so that is my final answer, negative 1/7. And just to go back and remind you that with getting common denominators, the trick is that you just multiply it by the other denominator. Instead of having to think through all those factors, I'm just going to multiply, so this one that was 28, just multiply it by 4, which was the other denominator. To make sure I balanced it, I also had to multiply the numerator by that other denominator as well. And then if I look at the 1/4, I multiplied the 4 by 28, so I had to make sure I multiplied the 1 by 28 as well. So we're going to do that exact same process when it comes to rational expressions like this. So these first ones are easy because they already have common denominators. So when I'm subtracting, I can literally just write x minus 5 over and then just write the common denominator that they have. In this case, that's 25x squared. And I'm done. I can't cancel anything out. Remember, to cancel something out, you'd have to cancel it here, here, and here. But nothing can do that. No, or I shouldn't say nothing can do that. None of these numbers can do that. And so we're done. So if I were to do that with this bottom one, they already have common denominators of x minus 4. So then I can just subtract the numerators normal. And if none of these things can be divided by the same thing, then you can't do it. So you might be tempted to look at the 3 and the 12 and maybe the 4 and try and divide it by something. But you can't do that because there is no term that can be divided by all of them, and so I'm done. Okay, so I'm going to have you guys try. These already have common denominators, so it should be pretty straightforward. But go ahead and pause the screen here and then write down your answer for what you got. And hit play when you're ready. All right, so check your answer with mine. In the first one, 8 minus 5 is 3. There was no other term. There was no plus anything else, so I didn't have to worry about it canceling in all 3 places. I just simply realized that 3 divided by 12 reduces to 1/4, so I made that change. Also in the bottom one, this is 4x minus technically 1x, so I did simplify it and write 3x just to get a more simplified version. Okay, so that's it. When they have the same denominator, it's really, really easy. And now let's spend our time focusing on ones when they do not have the same denominator. So just like before, we need to multiply the denominators by the other one. So for this one, to get common denominators, I'm going to multiply both top and bottom of that fraction by that bigger one over there that I circled. Now, before I do that, remember a trick is that if you can factor any trinomials, then do that. I'm going to work on factoring this to make my life a lot easier. So what are factors of 14? Well, I can do 1 times 14 and 2 times 7. Will any of those add to get me 9? Yes, 2 times 7 will, which means I can factor this to be x plus 2 and x plus 7. So why don't we rewrite the problem, but instead of this, write this. Okay, so I did that at the top of my screen, and now we can work on getting common denominators. So I'm going to write all of this over one fraction, and the denominator I'm going to do is just multiplying this one with these. So putting all those together would look like this. Okay, so what did the numerator have to do to get that? Well, the x plus 3 had to be multiplied by this denominator over here. So x plus 2, x plus 7. And then I'm subtracting the other term, which was 2x minus 5, times this denominator, x plus 7. Okay, I had to shift everything down to get that fitted in there. So what I want you to be careful, and I usually add an extra set of parentheses, is you're subtracting this whole thing. So I'm going to put an extra set of parentheses there just to make sure it's really clear that that negative eventually is distributed to everything in the red parentheses. So you're minusing this entire term, which means even when you multiply it by something else, that's still included in the minus. All right, so let's see, is there anything that can be canceled? Because I have a lot of terms. What I don't want to do is start foiling out all of this. That would be a mess. So look for things that are in all three. And I see that I have an x plus 7 here, here, and here. So all of those will cancel, and it'll leave it a lot nicer for me. So now I can write it as x plus 3 times x plus 2, that's just the first term, minus, remember keep this in parentheses, 2x minus 5, over, and then my denominator is x plus 2 times x plus 7. Okay, so from here there's nothing else that'll just simply cancel, so now I am going to have to start foiling all this out. Luckily it's not bad because I did cancel a lot. So the new numerator would be, if I FOIL that out, x squared plus 2x plus 3x plus 6. And then let's distribute this negative, minus 2x plus 5. Over, and I'm going to leave the denominator in that factored form. And the reason why I leave the denominator in factored form and not the numerator is because I'm hoping that when I combine like terms, like there in the denominator there was no plus or minus anything else, so I didn't have to worry about really adding or subtracting things together. But in the numerator there was, so that's why you do want to expand it all out, because we're hoping when we combine like terms, then maybe we will be able to factor after, and then maybe things will cancel, or it'll just look more simple. So let's see, what will cancel out here? This plus 2x and minus 2x, that will cancel out. And then also it looks like I can combine together this 6 and 5 and make 11. So let me just do all those things right on this line. So I'm going to erase this, and then write what I circled in yellow. I'm going to write that as 11. Okay, so I've done that, and now I just have a much more simple looking quadratic in the numerator, which is definitely a preferred form. So now I just want to think through, are there any factors of 11 that can add to get me 3? And there are not. So I can't factor the numerator any further, and so this is my final answer. Okay, so pause the screen if you need to look any of this over before we move on to the next one. Again, just to kind of like verbalize what the important steps were, is noticing right off the bat that you can factor this trinomial, and then also noticing that I could cancel the x plus 7s here, here, and here, so that way I didn't have to distribute as much. So make sure you're being really conscientious of that as we go throughout to make your life simple. And then really the only thing different in this video compared to the one yesterday is I wasn't adding two things together, I was subtracting. So in this step down here, it was important that this negative got distributed to both. That's really the only difference from today's video versus yesterday's video. All right, if you're good to go, then let's move on. If you need to pause it, pause it. All right, let's do another example where, again, I'm just subtracting. So same exact first step. I see a trinomial. I'm going to try and factor it to make my life easier right off the bat. So factors of 3 that add to give me -4 would be -1 and -3. Because if you multiply those together, you get +3, but if you add them, you get -4. So that means I can factor that blue part as x minus 1, x minus 3. So let's go ahead and write the fractions, or let's just write the problem as it is, exact same thing, but instead of the denominator as it is, I'm going to write the factored form that I just figured out. Okay. The other thing I could do right now, instead of doing it later, is I could just go ahead and distribute this negative to both just to take care of that now. So why don't I do that, and let's write a clean version. In fact, I like that. I think it makes it more simple. We didn't do that the last time, but I think that might be a good idea just to distribute the negative now. That way we don't ever really have to worry about it later when there's more things involved. And then this actually just turned into an addition problem, which is nice since it was minus a negative. Okay, so we've done all this, but we still haven't gotten common denominators. So now let's write it as one big fraction, and let's get those common denominators. So I'm basically just going to, well, write out my denominator with all 3 of those terms, and then adjust for the numerator. So the x plus 2 piece needs to be multiplied by this denominator, so the x minus 1, x minus 3. And then I have plus, and then my 2x plus 1 piece needs to be multiplied by this denominator, which says 2x minus 2. Okay, so now is where we really need to think critically, because I'm at the step where normally I would cancel out anything that's in all 3 terms. But if you look around, there's no terms, there's nothing that all 3 of them have. There's a lot of them where 2 of them have, like x minus 3, but then there's no x minus 3 here. Or similarly, I have like an x or 2x minus 2 here, a 2x minus 2 here, but then not a 2x minus 2 anywhere in these 3. So that's an issue. That means I can't cancel anything out. But that means this is going to be really, really complicated to distribute a ton of stuff. So let's look more carefully and see, well, is there anything where I can just like take out a GCF and then they would be the same? Because that is really the only other thing I could do. And the answer is actually yes. If we look at this term right here, I could take out a 2 of both of those things, and what would be left? Well, if I took out a 2, then it would be, that 2 would be gone and be x minus 1, which is exactly what's here and here. So let's make that a permanent change. Let's take out the 2, so then this is x minus 1. Now, what cancels is this x minus 1, this x minus 1, and this x minus 1. But this 2 right here will stay. Okay, pause it if you need to look that over and see what I did. I was very crafty in pulling out a GCF so that something would cancel. And that's going to be a really smart thing that you'll want to do if you ever get stuck like that. Please don't ever FOIL out like 3 things. That's going to get way too complicated. So pause it here because I'm going to erase what's at the top of the screen and start over with a nice fresh page. Okay, so I left this part at the bottom just so you could see where we left off, and let's write that out what we would have. I'd have x plus 2, just starting from the beginning, times x minus 3. My denominator, I know I'm not done with the numerator, but my denominator is 2x minus 2 times x minus 3. And then my other term in the numerator is, I'm going to write this 2 in front just because that's how we normally write it. So it's 2, because that was the 2 I pulled out, remember, times 2x plus 1. Okay, so now I can erase this. And now this looks a lot more simple for me to distribute things because instead of having 3 sets of parentheses, I just have 2 sets of parentheses. So I can distribute that like normal. So my new numerator would be x squared minus 3x plus 2x minus 6. Let's distribute this part as well. So plus 4x plus 2. And my denominator, I'm going to leave that in that nice factored form. And let's see now what things I can combine in my numerator. So it looks like I can put together these and this. So negative 3x plus 2x would be negative x, and then plus 4x would be 3x. So I'm going to erase all of these and just write 3x. And then I can also put together this minus 6 plus 2 to be minus 4. Okay, and then the only other thing I do before I say this is my final answer is see if I can factor what the numerator is. So are there factors of negative 4 that add to give me 3? So let's think. Well, I could do 1 and 4, and I could do 2 and 2. So what would add to give me 3? I could use the 1 and the 4. I could do 4 minus 1. So let's write out the numerator in that factored form. So it's going to be x plus 4 and x minus 1. And my denominator is 2x minus 2 over x minus 3. Now, you might notice that we had this other 2x minus 2 that we never did anything with. That was the other one that we didn't cancel out. Why don't we pull out the GCF? It's the same GCF as before. It's 2. Why don't we take a 2 out of that and write this as x minus 1 when I take the 2 out? The reason I would do that is because now this one and this one also cancel. So my final answer is going to, let me bring it up here. So my new numerator is x plus 4 over, and then I have this 2 that I pulled out. So 2 times, this got canceled, remember, so x minus 3. And I'll leave it just like that. Now the only thing I have to say is since I canceled these out, I do want to say something about how x cannot be 1. So I'll just say x cannot be 1. And then I'm good to go. And that's my final answer. So nothing was super different about that problem than other ones we've done. The only thing is that when things didn't cancel out, I pulled out a GCF and then they did. So I was just really careful just to make sure that things canceled out. Alright, so pause the screen here if you need to look this over before we do the last one for today. Alright, so for the last one, I'm going to kind of half have you do it, half me walk you through it. I want you to pause it here and see if you can figure out what would be the first step you do. If your mind blanks, it's good to have me to kind of like come in there and help you, but it's also good to give your brain a chance to think it through on your own. So pause it, see what your first attempt would be. Okay, so hopefully your first attempt is to factor that trinomial. So factors of 18 are 1 in 18, 2 times 9, and 3 times 6. Can I use any of those to get to 3? Yes, I can use 3 times 6 if I do 6 minus 3. So that means that I can factor this to be x, let's see, I was doing 6 minus 3, so positive 6 and a negative 3. I can factor what I just circled in red to these red binomials. So let's write out the problem, but instead of the trinomial I have, let's just write the denominator in that factored form. Okay, so that's what this would look like. And now let's go ahead and get, so before I said it might be a good idea to distribute the negative, but I don't have another term to distribute it to, so I really don't need to worry about doing that right now. Okay, so now I want you to pause again and think about, okay, now that I've recognized I can factor this trinomial, and I've done that, what's the next thing I should do here? Okay, so hopefully you got that the next thing you should do is get common denominators and write this as one giant fraction. So my common denominator would just be all 3 of these terms written under just one big fraction, and then compensating for the numerator. So the one that said 4x plus 3 over here needs to be multiplied by the other denominator, so x minus 3. Then I have my minus sign, and then this one with the 2x needs to be multiplied by the other denominator, which we wrote in factored form, so x plus 6, x minus 3. And again, just to say it one more time, I like to be really safe and put parentheses around that whole thing. Okay, so if you're good so far, pause it right now and see what would you do next if you're doing this on your own. Okay, so hopefully you saw there's an x minus 3 here, here, and here. So we can cancel all of those out, and let's rewrite what I would have. I would have 4x plus 3, and then let's distribute this negative while we're here. So minus, actually I take it back. I think that might be too much to write down. Let's leave that negative, but let's distribute this 2x. So 2x squared plus 12x. And I'll distribute that negative at the next step. Over, and then my denominator with the one of the x minus 3's canceled would look like this. Okay, so I kind of already said it, but let's distribute this negative now. I just didn't want to do too much at once. So 4x plus 3 minus 2x squared minus 12x over same denominator. And now from here I'll just see, is there anything I can clean up in the numerator? So it looks like I can put together this minus 12x plus 4x to be negative 8x. So I'm going to actually erase this and just write negative 8x. And then I can erase this term here because I used it to make that. And now let's just write the numerator in standard form. So I'll write this negative 2x squared first, and then I'll write the minus 8x and then the plus 3. Let me erase that and do that. Okay, so since we cannot factor this further, I am basically done, but I will say just one thing weird is always when we have a leading coefficient that's negative, and often when we have that, we just factor out the negative. So if I were to factor out the negative, it would be positive 2x squared, positive 8x, and then negative 3. And I am running out of space, so I'm actually going to write it over here. So again, if I factored out the negative, it'd be positive 2x squared, positive 8x, and then minus 3. So that is a more normal form to leave it because we always do like to have our leading coefficient be positive. And that changed nothing with the denominator. So the only thing I did is just take out the negative from the top, and this is my final answer. So it's not like this one here was wrong. It's just more preferred to write it like this with the negative taken out. Okay, and that's it. So this pretty much piggybacks 100% on the video from yesterday. So if you feel like you need a review, yesterday's video goes through it a bit more slowly. And we're just working on distributing the negative and just canceling out things and factoring just like before. So if all that made sense, you guys are good to go for today, and we are all done.